Hello guys, once more again. Now we are now doing the last part of the sequences and series. Now we are looking at what we call the sigma notation. So the symbol of the sigma notation is illustrated by this sign which we have over there, and this is what we call the sum or the addition of the terms. So we need to understand that the sigma notation, it is used to represent a series in a short term. Instead of writing the whole series 8 plus 11 plus 13 plus 15 plus what, we can symbolize that using a sigma notation and shorten that so that we can be able to get the proper answer fast. So what is important again, NB, is how do you calculate the number of terms in that specific sigma notation. So the number of terms is equal to the top value minus the bottom plus 1. Easy stuff. Easy stuff. Okay, example. How do we do the example of this again? We can say that evaluate the following. Let's say we're given the sigma notation of k is equal to negative 4 to 20 of 5k minus 2. This is easy. How can we evaluate this? We need to know how many terms are in there, okay? So we know that when you replace there, when you say in this is the general term, so that would be at k is equal to negative 4, this will be 5 times negative 4 minus 2. Then you use your calculator. That would be 5 times negative 4 minus 2. I'm getting negative 22. Then after negative 4, we get to negative 3, right? If I'm not mistaken. Then that would be when k is equal to negative 3. That would be 5 times negative 3 minus 2. And that will give us your negative 17. When k is equal to negative 2, because we are counting, right? This is term number 1, term 2, term 3 in that specific term, because this is where the starting point is, as you can see at k is equal to that. So that will make our lives a bit easier in that instance. Okay, so that would be that. Then k is equal to that. Then let's change this perhaps to black. Then when k is equal to negative 2, that would be 5 times negative 2 minus 2 equal to negative 2 there. That's negative 12. Okay, so we can literally just see that this is equal to negative 22, okay, minus 17 minus 12. If we look at the last term, which is 20 there, because the last term of this sequence will be on T20, as you can see here. So we can say when k is equal to 20, that would be 5 times 20 minus 2, which is equal to 98. So that would be minus plus until we reach 98, because that's the last term of that sequence. So in order for us to calculate, we can see this is a general arithmetic series. So we know that we have to calculate our Sn, and in order for us to calculate our Sn, let's use black there. We know that our Sn is always equal to n over 2 multiplied by 2a plus n minus 1 multiplied by d, or we can say Sn is equal to n divided by 2 multiplied by a plus the last term. Since in this instance we have the last term, what will be our n value? Our n is the number of terms, and if we say there's gonna be the top minus the bottom plus 1. What is our top value? Our top is 20. As you can see of this specific sigma notation, it's 20. 20 minus 4, so that will be 20 minus the bottom number, which is negative 4. Then we add that 1, then that will be 25. So our n value here is 25. Our a is the first term, which is negative 22. Our last term here is 98. If you wanted to use the common difference, our d here will be equal to negative 22, negative 17, minus 22, then we get 5. So our common difference here is 5. So now we can now calculate the sum of the first 25 terms, because we have calculated that the n is 25, which is equal to n 25 divided by 2 multiplied by our first term negative 22 plus our last term 98. Or you can use the other long method with the common difference. That will be s of the 25 will be equal to 25 divided by 2 multiplied by 2 times our a is negative 22 plus n minus 1. That will be 25 minus 1 times our common difference, which is 5. And after that, you can get your sum sum of the series, because this is the sigma notation, which is just representing the summation or the addition of the terms in the series. Now, how to write a series in sigma notation, okay? Because already I gave you in a sigma notation. Now, how do we arrive to that specific sigma notation? There are only a few steps. Of course, you first have to determine the general term. Easy stuff. Step number 2, we have to determine the number of terms. Number 3, we express it in sigma. We express the series in sigma. Then after that, you are good to go and you are happy. Okay, maybe we can make a small example, but I'll give you an example, guys, later. Just type example on the comment box or in the group so that you can be able to give you the example of this question. Thank you so much, guys. Tomorrow on Sunday, we'll give you the past question paper so that you can try to attempt after you've gained these fundamentals and understanding of these questions. Tango means thank you.